Steganography is Greek for steganos, which means covered, and graphia, which means writing. We've come across this before when we looked at Xerxes and the warning for the Greeks, where the writing was written on a board and then covered in wax, and that was an early form of steganography. So in modern systems, we can use steganography by hiding messages in images, audio, or web pages so that the message is hidden even in plain view. We talk about the medium that is carrying the message as the carrier file. So there's two forms of this: insertion, where the hidden text is added to the existing carrier, and substitution, bits of the carrier are replaced with bits from the message. One technique for steganography in images is to take each byte of an image and use the least significant bit, and use that for carrying the information of the message that you want to store. So we have here a byte, which is 8 bits, and the bits are arranged from right to left, with the most significant bit being on the left and the least significant bit being on the right. We use that one bit on the right, the least significant bit, as I said, to change and store the message content. When we use that, the actual overall effect on the image is not going to change, because it goes like here, for example, 25500, which represents the color red. It's still red and imperceptible to the human eye. So in this example, we have the bytes on the left of the image, and then we are going to hide the letter Z, whose ASCII code in binary is 10110101. So we take the least significant bit on each of these bytes and we write the binary that represents that Z. And so it takes 8 bytes to store the byte that, or the byte that is the letter capital Z. Steg analysis is where we're actually trying to find out whether an image has been used to store a steganographic message. And the approaches to this really depend on what information is available. So whether you've got the algorithm that was used to store the message on the medium, whether you've got the original medium itself, and whether you're able to actually know what the original plain text was for at least one of the messages. So in a steganography only attack, we don't have any information, and we just have the steganographic image or medium for analysis. A known carrier attack is where we actually have an original of the carrier. Known message attack is where we know the message. A chosen steganography attack is where the steganography medium and algorithm are both known. And chosen message attack is a known message and steganography algorithm are used to create a steganography media for future analysis and comparison. And then finally, known steganography attack, the carrier and steganography medium as well as steganography algorithm are known. So you know everything about it. There are tools that will try and find the hidden messages by brute force, and we can look for steganographic program signatures, and there's an application called StegSpy that will do that. If the original image is available, we may be able to look at the difference in size and hash value, and otherwise we can use things like complex analysis that looks for frequency distributions of pixels, and neural networks that can also be used. Now, of course, this could be further complicated by encrypting the message before hiding it in an image, and so it's actually a pretty secure way of transmitting messages. So there's various reports of the modern use of steganography. Osama bin Laden and the members of Al-Qaeda allegedly used images sent via email and websites to communicate with each other. In 2010, 11 alleged Russian spies, sleepers who were located in the US, apparently used steganography to communicate with their controllers, the people that were managing them. who worked allegedly for the SVR in Russia. That's one of their security agencies. The software that they used was proprietary and supplied by the SVR. It's used commonly to hide malware because it's hard to detect when downloaded, and that's an evasion technique in malware, which we'll consider later. It's also used to exfiltrate data used in industrial espionage. So in 2017, in the US, Dmitry Sazonov, who was working for a financial company, tried to steal code for the trading platform that he was working on by hiding the code in PDF files and then copying those files and sending them out of the network. Another thing that we can look at in forensic analysis is for deleted files. So we can search for deleted files that are deallocated but not erased. Most file systems use a table that holds information about where files are stored on the disk, and they are stored in clusters, although they may not be contiguous. So when a file is deleted, only the entry in the table is overwritten, so the data for the file remains on disk unless overwritten by subsequent file operations. And a secure erase adds steps to the writing a sequence of zeros and ones to the disk where the file was stored to completely obliterate the file. But as I've mentioned before, on a magnetic disk, there may still be recoverable if not done absolutely comprehensively. It takes time, so an awful lot of people wouldn't do it unless it's actually necessary. There are other ways of storing and hiding information on file systems. One is called slack space. So this is where disk space is allocated to a file, and because that's done in 512 bytes, if the file doesn't fill the available space, there is space left over, and that's called slack space. This may contain leftover remnants of other files, and so it can contain valuable information, but it can also be used to actually write explicitly to that portion, and so there are applications that will hide information in slack space. It's not particularly secure, but it's enough to keep things from casual view. Another thing is alternate data streams, which exists on Windows NTFS, which allows data to be allocated within a file using a stream, so that only the default stream is normally seen, but if you use a special command, you can actually look at the alternate data stream. Again, it's not a secure mechanism of hiding data, but it is a way of keeping things hidden and very easily retrievable from casual view. Linux has a similar system, not quite the same as Windows NT. Hidden files are not strictly hidden but have an attribute set, so they need to be explicitly referenced using the hidden option on command tools. So that's another way of malware in particular from hiding itself so that people just don't notice it by putting a dot in front of it, for example, on Linux and Mac will stop it from being seen. Changing the attribute to hidden on Windows will also stop it being seen by a normal user. Looking at crimes that have involved digital forensics, we're not going to go into too much detail, but give you an example of where forensics was able to solve crime. In 2005, there was a famous case of a guy called Dennis Rader, who was known as the BTK killer, a fairly brutal serial killer, who taunted police over a period of 17 years of killing people by mailing photos and puzzles and believing that he was never really going to be caught. Eventually, though, he sent a letter as a document on a floppy disk to police after taking another victim. And in case you don't know and have never seen one of these things, this is the thing that predated USB sticks. Well, in fact, it predated CD-ROMs and DVDs and then USBs as a way of transmitting data. But it was a magnetic disk and a little bit of cardboard that you inserted into the drive. So when they did a forensic examination of the disk, they found a deleted document, a Word document with metadata showing that the author was Dennis and containing a link to the Lutheran church where Dennis Rader was a deacon. And that was essentially what was able enable them to find him and then put together a case to prosecute him. In another incident, a guy called Matt Baker in 2010 was found guilty of the murder of his wife. She was found dead from a suspected overdose of sleeping pills, but the search history of Matt Baker's computer found searches containing overdosing on sleeping pills, and Baker had also searched for pharmaceutical websites and had begun to purchase Ambien, which is a sleeping pill. And they found emails on a server that essentially showed that Matt Baker was using the computer at the time of the searches. So it's sort of interesting in the sense of building up a narrative that is not simply good enough to find the search history. You've got to actually prove that within beyond reasonable doubt that he was on the computer at the time and he was the one responsible for those searches. So this is an interesting case because it shows you the intersection of physical and digital. So I've talked about the dark web and the fact that there are illegal marketplaces, and one of the most famous illegal marketplaces that kicked off these dark markets was the Silk Road. And Ross Ulbricht was eventually linked to being the administrator and originator of the Silk Road. He went also by the pseudonym of Dread Pirate Roberts, and he basically did a whole bunch of things where he leaked information in a variety of different ways. So he used forums like Bitcoin Talk, Stack Overflow, and had accounts used on this Silk Road site. So the accounts were using the same name and essentially linked him to these other communications. He then talked obliquely about Silk Road on LinkedIn when he was giving his opinions about what a market of this type could be like. He used a VPN server, but he used an IP address that was also hard-coded into the Silk Road source code. He used a real photo on fake ID and that he used to collect parcels, and the parcels were intercepted by the FBI. The fake ID was then also subsequently used to rent servers that should have been invisible as they were on the dark web. And then finally, he used a captcha on the login page of Silk Road that leaked his real IP address. And that was the point I was trying to make about both VPNs and Tor, is that if you're going to use these things, there are a number of different things within the browser that can potentially leak your location, so that it's not, if you really want to hide your tracks, then there are a number of things that you've got to be careful about. So another process in forensics is called reverse engineering. And this is where we sometimes collect malware, and that malware may be unknown, and we need to work out how it works. And so that's the process of reverse engineering. So the code is reverse engineered from the binary data in the program. So malware employs a range of different evasion techniques to prevent reverse engineering, and so it's sort of quite challenging to do this. And I've mentioned this before, but in 2017, Marcus Hutchins, who was found a web domain in the ransomware WannaCry, which when registered stopped WannaCry from spreading, so a kill switch in other words. And he then came under attack actually for doing this from denial of service from the Mirai botnet. WannaCry itself was unusual because it exploited two vulnerabilities in Windows called Double Pulsar and Eternal Blue, and they had both been stolen from the NSA, the National Security Agency in the US. So it just goes to show, when these things fall into the wrong hands, the sort of devastating consequences of it. The story of Marcus Hutchins doesn't stop there. Because he attended a conference in the US and was arrested before he was leaving to go back to his home in the UK, and was accused of actually being the creator of banking Trojans, and the case took a couple of years to come to court. He was placed under house arrest during that time in the US, and eventually was let free after a minimal amount of serving time, but essentially he had been under house arrest for 2 years. He did a plea bargain where he admitted to actually creating the malware in the first place. So another situation of people who use their creative talents in the wrong way and then eventually started working for the security firms and sort of the right side of things, but their past caught up with them.